Okay, let's go ahead and get started here. Good afternoon. I'm Ron Smith from the OBIC Bioproducts Innovation Center. I want to thank you for joining the OBIC Bioproduct Network. This is our latest presentation as part of our educational webinar series. Today's technology webinar is on the topic of advanced biorefining, entitled Producing High-Value Drop-In Biopolyols Using Low-Cost, Small-Scale Facilities. And we're very fortunate to have Mark Perry from Battelle Memorial Institute as our presenter today. Let me just cover two real quick things. First, if you haven't already done so, if you can mute your audio to just reduce any interference we have during the middle of the presentation. And if you have any questions, you can either use the chat function that's up there in the right-hand corner, or if you want to, you can just send an email here to our student assistant, Katie Schrader, at schrader.191@osu.edu. So I'd like to start off by introducing Mark Perry. Mark is a project manager at Battelle Energy and Environment. Mark has chemical engineering degrees from the University of Dayton and from Ohio State University. He has 20 years experience in the chemical and materials industry. He's been program manager for Protero's startup biofuels pilot photo bioreactor. He's also been director of R&D for startup Resin Systems Incorporated, which is a polyurethane chemical company. And has also had experience with polyol chemical scale-up and polyurethane application development for Bayer Polyurethanes, Lyondell Chemical, Arch, and Arco Chemical. Okay. And with that, we're going to go ahead and pass it over to Mark.
Very good. Thank you, Ron. I appreciate that introduction, and thank you to everyone attending today. I advance this slide to the first one that shows a cartoon, if you will, of the process that we envision. In the background, you'll see the bioprocessing facility, and in the foreground is a chemical conversion part of the facility. So Battelle has developed a technology to produce biopolyols from a pyrolysis oil. And at a high level, we take low-cost, non-food biomass, such as wood chips, sawdust, agricultural grasses, bagasse, corn stover, etc., to generate an intermediate or crude bio-oil. We also produce biochar as a co-product. In the second step, we take that bio-oil and convert that to a biopolyol, which would be used in polyurethane applications. So Battelle has developed this technology, and we're at a position where we're seeking strategic partners and investors in order to launch a new company to spin out of Battelle. So a little background on Battelle, and perhaps many know this, so I'll be brief. We opened our doors in 1929 at 505 King Avenue in Columbus. We are a contract research and development organization, and our mission is to solve technical challenges and to commercialize new technology. So over the past 85 years, we've developed a number of technologies. Some of these are shown as example here. We developed the Universal Product Code, or UPC, for scanners. We developed the Xerox process for photocopying. We developed a technology for microreactors and Fischer-Tropsch, spun out into a company now titled Velocys. We're currently working on spinning out technology in liquid screening, or LS10 bottle scanning, which would be used for airport screening. And our most recent venture here is with our modular renewable chemicals, where we intend to spin this company out this year in 2014. The Battelle has a rich history in developing and licensing and commercializing bio-based chemicals through our research partners, etc. We've developed and commercialized 6 products with a number of R&D 100 awards, quite a number of patents granted and other patents pending, all in the areas of polymers and coatings and composites using plant-based feedstock. Some of these licensed technologies include a toner based on soy that, in fact, Ohio State University is using in their photocopiers. BioBent, where it's a soy-based composite, where BioBent is located in Marysville, Ohio. Woodbine Products, which is a soy-based hand cleaner in Medina. Polyol in Avon Lake. Emery Oleochemical in Cincinnati. And Momentive Specialty Chemicals here in Columbus, Ohio. And in fact, the technology that we have developed on pyrolysis to polyols, we've done quite a bit of that development in the OBIC lab that is located at Battelle in room 5047. And that OBIC lab has been instrumental in the development of this technology I'm describing today. On the front end side of our technology is a thermal conversion process, and I point out as well that Battelle has commercialized a number of technologies. I explained the Velocis technology, which is a microchannel reactor for doing Fischer-Tropsch. Battelle has designed, constructed, and in fact operates the United States Air Force Assured Aerospace Fuels Research Facility at Wright-Patterson Air Force Base. Several years ago, we developed gasification technology, a thermal conversion technology, trademark Silvagas, that is now owned by Rentec. And so one way to look at this technology of pyrolysis to polyols is as an intersection of experience that Battelle has joined together in these 2 different areas. And pyrolysis is thermal conversion done anaerobically. So it's taking the biomass up to around a 500 degrees C in the absence of oxygen. It generates a vapor, and we condense that vapor in order to capture a crude or intermediate bio-oil. Now that bio-oil itself has limited commercial value. It's highly oxygenated, it's acidic, it is somewhat thermally unstable, meaning that it will continue to advance and polymerize, and it's not directly miscible in hydrocarbon fuels. So one approach that the industry has taken would be to take that bio-oil and to hydrodeoxygenate it in order to create a liquid transportation fuel. The approach that Battelle is taking is perhaps at a higher technology level readiness, where we're taking the bio-oil and doing a number of reaction and conversion steps, most principally propoxylation, in order to generate a biopolyol for the urethane industry. The current state of our technology is we have scaled to a pilot. We have 1 ton per day of biomass to generate bio-oil. We have around 60% yield. So taking 2,000 pounds of biomass will generate 1,200 pounds of this crude intermediate bio-oil. And then through our chemistry and propoxylation, we ultimately generate 1,800 pounds of polyol from that original 2,000 pounds of biomass. Our overall bio content in our polyol is in the range of 40 to 45%. If we look at the polyol market, we're excited in that it's a fairly large market, a $20 billion plus market globally, with a healthy growth rate, a CAGR of 7.5%, and specifically in the biopolyol area, projected to more than double in the next 3 years. To make a distinction, the soy-based or palm-based or other castor oil-based polyols, are all coming from a natural oil, whereas the technology that we are talking about today is a pyrolysis oil-based polyol. So it is quite different in terms of the constituents in that crude bio oil. We've done some formulation around our polyols and urethanes. The polyol that we are currently intending to commercialize and market first is a high functional, so a highly branched polyol at a high hydroxyl number, and it would be amenable to rigid foam applications. And so we did some work at an outside lab to explore this formulation in both pour-in-place as well as spray foam applications. Quite interesting, we see the cell structure, the urethane foam cells, are quite uniform. We believe that is giving some advantage as seen in better thermal insulation. So our R values are higher than a control rigid foam. We have lower friability or brittle crumbling. We see higher compressive strength, likely due to the high functionality and the cross-linking. We meet fire standards, for that industry, and we show a higher reactivity, which has commercial value to spray foam application, where getting rapid green strength can allow you to process and apply more board feet of spray foam insulation per shift per day. As I explained at the outset, we intend to spin out this company and stand it up in 2014, and we are looking for strategic partners and investors. The mission of this company will be to design and build, own and operate, and eventually license a network of these modular renewable chemical facilities. We'll build and commission our first commercial system. The scale that we intend is to process 10 tons of biomass per day, which is a 10x, 10 times scale up of the pilot that we're operating today. And likely we will be working with a partner to convert the bio oil into a biopolyol, simply as a means to conserve the capital investment, recognizing that propoxylation capacity is available in the market, and so we'll either work with a toll producer or potentially a strategic partner. We also look for other strategics in terms of market reach, sales and distribution, etc., and financial investors to essentially validate our business and commercialization plans. Our approach has been to be very deliberate and disciplined in terms of minimizing risk with the least amount of capital invested. Our technology is designed to be low capex and low opex. It's very compact, and you'll see in the photo the 1 ton per day system fits on the back of a 53-foot trailer. We have done our scale-up calculations for the design of the 10 ton per day, and that will also be fitted on a single trailer. Now that has implications for our business plan in that rather than shipping low energy density biomass to a processing facility, our system is a modular system where we drive the bio oil machine to the source of the feedstock. Right? That allows us to be flexible in terms of feedstock going into the bio oil machine, as well as allowing us to control feedstock costs, so that the bio oil machine could be moved from feedstock source to feedstock source, depending on cost and economics. We believe we have a very good product in our biopolyol, and based on our economics, we see early revenue and a positive cash flow from our commercial demonstration unit. And in terms of growth of this company, our business model is one of replication. And so replicating 10 ton per day, 100 ton per day, and perhaps a little bit larger machines, but distributing them globally out in the field is where we're headed. We have quite a number of patents that have been applied, over 20 and counting, and we're very excited about the next step of this venture. So to kind of wrap up what I have prepared is that Battelle has already invested and taken this technology to a point where we have a pilot facility, and that's been over the last 3 years. We're seeking validation from the market and strategic partners and investors, and we'll be 2 years to commercial production. So that's the design and build and commissioning of a 10 ton per day plant. And then as we replicate and grow the business, that will be through most likely project financing, where you would debt finance additional units as we grow. We're looking forward to engaging both the investment community and strategic partners, and I thank you very much for listening today.
All right, thanks very much, Mark. We have had one question while you were presenting. The question was, in the conversion of 2,000 pounds of biomass down to 1,200 pounds of bio oil, where does the residual 800 pounds, or what is the use for the residual 800 pounds?
Yep, so the residual is in that biochar.
Okay.
Right, and depending on the feedstock, there will also be some inorganic ash that's collected out of the bottoms of that.
Okay.
And additionally, there are some non-condensables that would go overhead. In our design, we capture those non-condensables as a vapor stream and push them back through the pyrolysis reactor. So it becomes a kind of a closed loop feed source back to itself.
Oh, awesome.
So, Mark, this is Max. One of the things that we've heard about using biochar as a soil amendment, and you use the term a green fertilizer. Has Battelle done any studies to quantify how that biochar compares to conventional fertilizers or compost, or is that just more literature work that you've done thus far on that?
Right, that's a good question. No, Battelle has not done specific work in the biochar area. We have had a number of conversations with parties that are interested in taking our biochar and doing their own independent assessments of that. Our focus has been, quite frankly, on the higher value chemical outcome.
And I'm on a roll, Mark, so I want to keep going here. When you go from the 1 ton to the 10 ton, it looks like from your schematic you go from a mobile unit to a grounded unit. So then you're going to have to deal with the logistics of bringing your biomass into that 10-ton facility, correct?
That is, yeah, so the cartoon graphic is for a co-located plant, meaning that the pyrolysis is co-located with the polyols chemical plant. So in that case, yes, there will be logistics in and out of it. The other more likely model is one of a hub and a spoke.
Okay.
And so we would look to either build or utilize existing infrastructure on the propoxylation side, and we'd have distributed bio-oil machines out at the source of the feedstock, and we would ship oil into the polyol plant.
Okay. So with the mobile unit, you're currently at a barrel or a ton a day. How high do you think you can get that mobile facility? Could that get up to maybe 3 to 5 tons per day?
I'm not sure I understand the question. Are you asking the pilot unit, what's its capacity?
No. I understand the pilot is a ton per day, but if you were to increase the capacity through, this looks like there's some free space on that semi-unit, could you get that up to 3 to 5 tons per day, or is a ton per day really the limit on the one semi-unit?
No. 10 tons per day is the design on the back of the 53-foot trailer.
Oh, okay.
So right now I have a 1 ton per day on that, and I will build a mirror image of that, but at 10 tons per day. And so,
Gotcha.
Based on the reactor design, I have a couple degrees of freedom. I can go higher, right? But then that makes it difficult if I'm traveling, under bridges and others. More effective is I increase the diameter of my reactors.
Gotcha.
Which also has a multiplication factor, right, in terms of diameter square, et cetera.
And is the storage of the bio oil as part of the trailer, or is that a separate tanker unit?
Right. So in that model, the bio oil our model is to put that into totes, and then those totes get shipped. Or once we get up to scale, then it would go directly into a 6,000-gallon tank truck.
Okay. I've expended my questions. Thank you. Very helpful.
Okay, since we're kind of a smaller in number today, are there any folks online that want to unmute and ask a question to Mark while we got him here handy? Okay, hearing none. Mark, I want to thank you again for presenting today. Sure appreciate that. Also want to thank the folks who tuned in to participate today. We hope that you will join us again for our next OBN event. Our webinar for February is going to be on the topic of algae-based feedstocks, and so we're in discussion with a couple of companies right now to present on that topic, so we're going to have at least one, and if not two. And also for anybody else who logged in today, if you're not yet a member of the OBIC network, I encourage you to visit our website and find out more about us and download a membership application. Membership ensures that you'll have access to great programming opportunities like our upcoming networking events and also to our annual meeting, and to keep your company at the forefront of happenings in the bioproducts industry. Again, I want to thank you for participating, and we look forward to having you join us again.
One quick note for everybody. Yesterday afternoon, on the OBIC website. The information on the October Bioproduct World Showcase and Conference went live. So it's going to be hopefully a major conference here in the Columbus area that first week in October, and looking at it, bringing in the folks globally who are offering bioproducts, as well as the procurement officials from the government and retail buyers who have been looking for the opportunity to purchase bio-based products. So preliminary information is on that website. We'll be continually updating it, but just ask everybody to put it on their calendar and look forward to seeing you in Columbus October 5 through 8.
Yep. And the initial link to that is bioproductsworld.org.
Great.
Thank you very much.
Thank you. Bye-bye.